Assalamu alaikum dear students. This is our next problem. Problem having been chosen from the book Modern Physics by Kenneth S. Crane. As usual, we first come to its statement. Okay. Find the frequency of the current that results when a voltage difference of 1.25 microvolt, micro meaning 10 to power minus 6, okay, milli means 10 to power minus 3, micro means 10 to power minus 6, nano means 10 to power minus 9, okay. Find the frequency of the current that results when voltage difference of 1.25 microvolt is applied across a Josephson junction. Okay, dear students, we are coming to meet this term first time in our problems, in our videos. This term is mostly used in electronics as well as solid state physics. This is a relatively new concept, not very much, but because we are studying modern physics, so you can see that various terms like in our previous problem, Weidman, Franz rule, similarly Josephson, etc., are usually not covered by general physics books like Raymond Survey, John Jute, Young Friedman, etc. Okay, so this is a relatively new concept, and for the time being it is sufficient for us if we use the result of these concepts or theories in solving these problems. Okay, in some subsequent video we may come towards the philosophy or theory of these concepts in separate lecture. Okay, so for the time being, because we are just solving problems, okay, so it is sufficient for us if we just use the result of such theories, concepts. Okay, now we come towards helping tools. Dear students, its tool number 1 has been demonstrated in 3 alternate versions. Okay, all the 3 alternate versions are 100% same, just there will be difference of wording, etc. Okay, because different authors have their own angle of thinking, their their wording may be different, their style may be different, but main thing is always the same, because they cannot deviate from the spirit of philosophy. Okay, so first we come towards the first version of tool, helping tool number 1. Okay, in this version AC Josephson effect has been described. Okay, this is AC Josephson effect. Similarly, there is DC Josephson effect. Such concepts are more widely used in electronics. Okay, AC Josephson effect. When a voltage capital V is applied across a Josephson junction, the phase difference phi increases with time at the rate nu equal to d phi over dt equal to 2ve over h or h cut h. Okay. Planck's constant h, not h cut. H cut is actually Planck's constant h divided by 2 pi. But here 2 pi is not involved. This is simply h Planck's constant. Okay. Dear students, this V like symbol is called nu. N U. I hope. This is called nu. Similarly, d phi over dt. This symbol is called phi. Okay. Dear students, one symbol is mu mu m for monkey, and one is nu n for nest. Okay. Similarly, one symbol is phi p for pocket, and one symbol is psi psi, p silent and then psi. Okay. In order to make this sense clear that we are pronouncing these Greek alphabets correctly, I have introduced a separate tool which will authenticate my pronunciation about these alphabets. Okay. When a voltage capital V is applied across a Josephson junction, the phase difference phi increases with time at the rate nu equal to d phi over dt, that is derivative of phi with respect to time. This becomes equal to 2 capital V small e over h, where V is applied voltage, E is elementary charge, and h is Planck's constant. Now we come towards its alternate version, second alternate version. Okay, F equal to 2ev over h. Okay, this result, known as the AC Josephson effect, has also been observed experimentally. Dear students, here the only difference is that here in place of nu, f is used. Okay. Actually, nu is also frequency, and angular frequency is denoted by omega. Okay. Here omega is not used, here is nu is used. So this expression is quite equivalent to above expression. Okay. Nu also denotes frequency and f also denotes frequency. Instead, in place of nu, there is an alternate term omega. Omega denotes angular frequency. Okay, here angular frequency is not involved, simple frequency. Now we come to its third version. Okay, third version says Josephson also predicted that if a DC voltage capital V were applied across a Josephson junction, there would be a current that alternates with frequency f, given by f equal to 2e capital V over h, where E is elementary charge, V is applied voltage, and h is Planck's constant. This result, known as the AC Josephson effect, has been observed experimentally. Okay, now we come to tool number 2. This tool has been taken into consideration so many times, so we skip this tool. Okay, third tool is about Greek alphabets. Here the purpose of introducing this tool is just to ensure that we have pronounced these Greek alphabets correctly. Okay, so we come to the relevant okay, our concerned tools. This is, dear student, this is phi, phi phi. This is capital phi and this is small phi. Okay, phi. This Greek alphabet has been used in our, okay. Similarly, one Greek alphabet is psi psi. Its symbol is capital this and small this. Okay, this is omega. Uh, this, okay. Similarly, now we come towards the new. Yes, this is new. New capital and small this v like. Okay, so in our expression, this new has been used. This phi has been used. Similar to phi, there is symbol psi, and corresponding to symbol nu, there is symbol omega. Okay, now we come towards the solution. We know that according to AC Josephson effect, F is equal to 2ev over h. Then just we have used values. Okay, value of elementary charge. Okay, here this value is given in the table which we have introduced as a helping tool. Into v is given as micro, 1.24 micro. Micro stands for 10 to power minus 6 divided by Planck's constant h, whose value is this. Next, simplification, just simplification. In place of micro, it will be replaced by 10 raised to the power minus 6, and 10 raised to the minus 6 will be shifted to denominator, and it will become 10 raised to the power plus 6 in the denominator. Okay, so next, just a few conversion factors. Okay, using a few conversion factors, value of f has become equal to 0.60 into 10 raised to the power 9 coulomb volt over joule second. And we know that volt is equal to joule per coulomb. Here coulomb will be cancelled with coulomb and joule will be cancelled with joule, and hence our result will become 0.6 into 10 raised to the power 9 second inverse. Okay, because second is appearing in the denominator, and we know that second inverse is called hertz. So in place of second inverse we write hz, hertz. And now this is 10 raised to the power 9. If we convert it into 10 raised to the power 6, then this 0.6 will be converted into 600. Okay, and this is called million or mega, so we can write this quantity as 600 megahertz. In place of 10 raised to the power 6, we have used capital M, remaining nothing left. Okay, so this is the end of our problem. This is the end of our video. Till next video, Allah Hafiz.